Stop trying to solve the entire puzzle perfectly, because it might just be the reason you don't finish decision making on time. I'm going to show you the GRIT method so that you finish logical puzzle questions quicker and more accurately. My name is Farhan, I'm a junior doctor and I've helped over 100 students get into medicine and dentistry across Australia. And today, you are going to learn how to solve logical puzzles by establishing the goal, drawing simple tables or diagrams, locking in concrete information first, and testing hypotheses. So let me introduce you to the GRIT method, which is, first of all, we need to state the exact thing that you're looking for, establish the goal. Then we represent it by drawing a simple table or a diagram or an equation. We then identify concrete pieces of information, which is filling in clues that are 100% certain before the vague ones. And then we test the remaining options and we consider worst case scenarios if we have to. So let's start off with the goal. So the intention here is to have a clear goal in mind for every single question. This is quite literally as simple as reading the question and understanding what the goal is. Because sometimes you'll realize that solving the entire puzzle is not a necessity. Sometimes it's not required to adequately answer the question. Sometimes it's impossible to solve the entire puzzle, but you will be able to answer the question from what information you do have. So if you're stuck there trying to solve the entire table, but you've got the answer in front of you the whole time, then that's where you're losing time. Next is to represent, to draw a simple diagram or a table. So look, you should be drawing out diagrams whenever you can for these questions. It helps you visualize what's going on and it stops you from getting lost during the question. The types of diagrams that I like to draw out are grid layouts, which I'll demonstrate for you in the questions, tree diagrams, sequential orders, and sometimes even algebraic equations when it comes to more of the numeracy-based questions that we'll go through later on in the video as well. Next is to identify concrete pieces of information. Concrete information in a nutshell means information that cannot be refuted and is 100% certain. For example, Aaron came second in a race. Not third, not fourth, just second. Non-concrete piece of information is something that gives you some clue, but is still fairly vague. For example, a statement like, David finished behind Eric in the race. Well, we know that if here is first and here is last, then David's going to be below Eric in the order. Now, do we know whether or not Eric was third, fourth, or fifth? We don't know. Do we know whether or not David was directly behind Eric? We don't know. For all we know, David could be last, Eric could be all the way here. So the fact of the matter is, we don't know, which is what makes this a non-concrete piece of information. And there's no need to go from top to bottom. Concrete pieces of information are littered literally all throughout the statements. And oftentimes, the best pieces of information are in the middle or at the end, not at the beginning. So don't worry if going top to bottom is not making sense. Instead, you need to focus on acquiring the concrete statements by looking in the middle or the end of the statements that they give you. And lastly is to test hypotheses. It's unfortunately a necessary skill for the harder logical puzzles. There will come a stage in some puzzles where the best thing, the only thing that you can do is test hypotheses. So it's asking yourself the question, does everything fit together if Maria has an orange shirt? If it does, perfect. If no, then you test another hypothesis, like does everything fit together if Maria has a pink shirt? And then you repeat like that. It's essentially an educated guess and check. But every single other tip we've just gone through will narrow down what options you can guess from. It's last resort, but it is sometimes used in logical puzzles. And the other part of testing hypotheses is imagining the worst case scenario. The reason why this is good in decision making, because if you think about it, decision making is all about making safe decisions. So you want to take a risk averse approach, making no assumptions. It's basically saying, if this works in the worst case scenario, then it works every single time. So this is the GRIT method in a nutshell. And it's just one of the many methods that I have for the UCAT. And if you want all of my methods and frameworks in one space, then just click the first link in the description below. Otherwise, let's go through some worked examples, starting off with this one. So feel free to have a go at this, trying to apply the GRIT method. Pause the video now and have a go. Okay, so let's go through this question together. First of all, let's establish the goal. Who paid $85 for that activity? So as soon as we figure that out, we know that we're in the clear. We don't have to solve the rest of it if we don't have to. So the next is to represent. So I'm going to draw a grid table here. This is my favorite kind of table to draw out. So we've got Alex, Beth, Chris, Dana, A, B, C, D, and we've got the activities and the price that they paid. So this is the kind of table that I like to draw out. I might make that a bit nicer so I can write in it. Okay, So let's go through the statements now, trying to identify concrete pieces of information. Alex did not spend the lowest amount, but spent $15 less than Beth. So this is not concrete, other than the fact that we know that Alex is not 45. But we know that Alex could be 55 or 70, not 85 though, because he spent 15 less than Beth. So Alex is somewhere in here. It's not exactly a concrete piece of information. So I'm going to keep on going so that I can see if there's anything I can fill out automatically. Dana didn't do kayaking, but their activity cost more than Chris. Again, can't do much. Chris chose pottery. Okay, so there is our first piece of concrete information. We can put pottery in the activity section there. Alex did not select cooking as their activity. Cool. Beth participated in cooking, so we can put cooking here. And the cooking class cost less than rock climbing. So unfortunately, we don't have all that much to go off in terms of concrete information, but we can use some of the non-concrete information now to fill in the rest of the table so that we can end up figuring out who paid 85. Remember the goal at all times. So if we have a look at this statement right here, Dana didn't do kayaking. Then, and have a look at, what's left here, rock climbing and kayaking. So if Dana didn't do kayaking, the only thing left for her is rock climbing. So RC for rock climbing here, and then by extension, K for kayak for Alex. Now, in terms of other information that we know, so we know that Beth's activity was more than Alex through the first statement here. We also know that Dana's activity was more than Chris's. So Dana is more than Chris. And what this helps us do is figure out what the prices could be. So we know that Alex can't be 45, Alex can't be 85. So he can only be 55 or 70. Now, this is where we actually have to use a bit of hypothesis testing to get to the bottom of our answer. So let's just have the hypothesis that, for example, Chris is 70. So by then definition, if Chris is 70, then and Dana's activity is more than Chris, this has to be Dana. But then that leaves Alex here with a case where he would be 45 and Beth would be 55. Now that can't be the case because we know that Alex spent $15 less than Beth. So if we leave Alex with 45, then he can only have spent $10 less than Beth. So that doesn't work out. Now, what about if we have Chris as 55? Well, we know Alex is either 55 or 70, so that means Alex is here. That means Beth must be here because that's a $15 difference. And that means Dana is here, but that doesn't meet the constraint of Dana having to cost more than Chris. Here, Dana is less than Chris, so that one doesn't work out. And so the only thing that we're really left with here is Chris being the person that had 45. So we can pop that down now as 45. So what are we left with? We're left with Alex, Beth, and Dana with 55, 70, and 85. And we can use the information in front of us now to narrow it down. So, for example, we know that Alex is either one of these two, is 15 less, and we also know that now the cooking class cost less than rock climbing. So in terms of pricing, rock climbing was more than cooking. And if we know Alex was less than Beth, what's Alex here? Kayaking. So we know that Alex was less than Beth. We end up getting this order: kayaking, cooking, rock climbing, which ends up then being, in these numbers, 55, 70, and 85. So in this case, for our answer, who paid $85 for their activity? The answer is D for Dana. So in this case, we actually did need to fill out the entire puzzle to get to our answer. And hopefully it shows you the grit method in action. Identifying the goal, representing it in a table, looking through concrete information, and then testing our hypothesis if we need to. Now, let's go through another question. Pause the video now, and then we'll go through it together. All right, so let's go through the question together now. As always, we have to think about the goal. Which of the people was third to arrive? As soon as I've got my information for who's third, then I've got enough information to proceed. So let's go for it. I think this is one of those questions where I'd probably depict it in a sequential order. So we've got first to last in this case. So Ben was immediately followed into the room by Carlos. So I'm not going to put it in the actual line here. So it should actually be the other way around. But the reason I'm not doing that is because Ben and Carlos could be somewhere there, or they could be somewhere here instead. So because I don't know that for sure, I'm just going to put it somewhere below so that I'm not messing up the line. Next, Diana arrived after Emma. So we've got Diana, we've got Emma. I'm leaving a gap because we don't know if it was immediate. And then, but immediately before Felix, who was not the first to arrive. So we know that Felix goes here. And Grace was later than Emma. So Grace has to be somewhere here, who arrived after Ben. So we just know that Grace has to be somewhere maybe here, or could even be here potentially. We don't know. We don't have enough information. But what we do know now is enough information to comfortably say who was the third to arrive. And that is the answer of B for Emma. So remember, you don't need to finish the whole puzzle in order to have your answer. Sometimes the answer's right there in front of you without you needing to complete it all. Let's go to the next question. Feel free to pause the video here and have a go. Okay, so let's go through this now. Unfortunately, for this question, we don't really have a clear goal. It's one of those, which of the following must be true, which does come up now and again for the logical puzzle questions. So what we're trying to see, at least, is, okay, we're trying to find out whether or not A, B, C, or D drinks this or plays that. So what do? We represent it in a table. A, B, C, D, and then we've got the sport and we've got the drink. So this is how I'd be writing it out. So let's go through the concrete piece of information. A plays tennis. So we're going to put down tennis in this box. B drinks coffee. The person who swims is not C. I'm just going to put this here just so I remember. D does not drink tea. So no tea. The cyclist drinks water. Now, this piece of information might feel a bit iffy for us. We're not too sure what to do with it, but it is actually quite an important piece of information because it means that there has to be a combination of cyclist and water somewhere. So it can't be A, it can't be B, because we know through the concrete piece of information that we've been given, tennis and coffee, that the cyclist and water combination can't go into A or B. So it has to be either C or D. So I'll just put that sign there to remind us. And then we know C does not play running. So if C doesn't run, and we know that cyclist and water has to go somewhere within C or D, then it must be C who does cycling and drinks water. Now, at this point in time, when we've gone through basically each piece of information we can, always recheck and see if you can answer the question. Which of the following must be true? B plays swimming? We don't know. C drinks water? We do know that. So we actually know this for sure, for certain. So we can just select the answer of B and move on from here. We can't waste time trying to finish the entire table. And I think if you try to finish this entire table, you'll realize you can't. You just don't have enough information to do so. So in cases like this, always recheck if you can answer the question from what you have in front of you, because you might just save yourself a bunch of time. We've got one more question here, so feel free to pause the video and have a go. Alrighty, let's run through this one now. So we've got Anna, Ben, Claire, David, and Emma. Having a look at the goal, which of the following statements is true? Can't do much with that. And they are wearing jackets and scarves of different colors. So I'll put scarves here and jackets here, just because top to bottom, that's how you'd wear them. Helps me remember. Okay, so no two people wore jackets and scarves of the same color. We can't do much with that. That's more like a condition statement, right? Anna wore a green jacket. We can absolutely do something with that. So green jacket here. And her scarf was neither red nor blue. So not red, not blue scarf. Just keep that in mind. David wore a red jacket. Lovely. And Claire wore a brown scarf. Cool. So nice piece of concrete information we can work with. Now we've got the color of her jacket was the same as the color of Anna's scarf. So the color of her jacket, I'm just going to have a star here, is the same as Anna's scarf. So we know that Anna's scarf cannot be red. It can't be blue. It can't be green because you can't have the same jacket and scarves as the same color. And we also know it can't be brown because if this was brown, then what happens is this ends up becoming brown. And we know that the brown-brown combination can't happen. So we're actually only left with one color here, which is yellow. And this is yellow. So this is what we're left with by the end of the first run. So let's check if we can answer the question. Claire wore a red jacket. Well, that's not true. We know she wore a yellow. David wore a red scarf. That's not true. He can't have because he's wearing a red jacket. David wore a yellow scarf. He can't have because Anna is wearing the yellow scarf. And we're left with D by elimination. But you can see D also makes sense. Ben wore a blue or a brown jacket. That's all that you're basically left with. Because we've got green here, yellow here, red here. It's got to be blue and brown between Ben and Emma in this case. So Ben had to have worn a blue or a brown jacket. Alrighty, let's kick on into our next question. Feel free to pause the video here and have a go. So now that you've had a go at this question, let's run through it together. The goal is basically to answer one of these positional questions. So we have to figure out what the positions are going to be. Let's represent it in a diagram. It's beautifully on the screen already, so I'm not going to bother drawing something out here. On the day, you're just going to draw it out on your little paper anyways. And let's go through the statements to find the concrete piece of information. Alex sits fifth from the left with Bella and Carlos on each side. So 1, 2, 3, 4, 5. This is Alex and Carlos on this side. Diana sits as far away from Bella as possible, so Diana's going to have to be here. Ethan sits next to Carlos, so Ethan can only really be here. Fiona does not sit next to Bella, so Fiona could be here or here, I don't know. But George sits 3 seats away from Alex, so 1, 2, 3. We know George is here, therefore Fiona is here. So, I can see here from the answer options, this has to be Hannah. Cool. So from this, we've actually completed the table now, and we can answer the questions. Hannah sits on the far left, not true. Ethan sits next to Bella, not true. George sits next to Carlos, not true. Diana sits on the far right of the row. So we've got Diana here, so D is our answer. So far, we've gone through logical puzzles when it comes to statement-based questions. Basically, every single one of the questions we've done so far, statement-based. But there are going to be some questions which are a bit more number-based. So let's work through those now. The only thing that changes between them is instead of drawing a simple table or a diagram like the grid layout or the sequential layout we've done just then, I tend to find that I'm writing more equations for these ones instead. So pause the video here and have a go at this question. All right, so let's go through this question. So our goal here is to find how many male students there are in the conference. Now for a question like this, I like to represent it in maybe a tree diagram and an equation format. So we've got 32 people at the top here, so everybody, and that's split off into males and females. So M, F, right here. Now we have to figure out how many males and how many females there are. And we're given enough information to be able to solve that. So there are 6 more females than males. Or in other words, if you get the number of males and then the number of females, you end up getting 32. Or in other words, M plus 6, this is the same thing, is equal to 32. Because we know that there are 6 more females than males. I'm just representing it in terms of males so that we can find the number of males algebraically. So this ends up giving you the number of 26 equals 2M or M equals 13. So we know that there are 13 males and then by extension 19 females. Now 15 of the 20 professionals are female. So we know that there's going to be 15 female professionals. So in here, 15 professionals and therefore 4 students. Now remember the question, how many male students are there in the conference? And we can work backwards to kind of figure this out. We know that if there's 15 out of 20 are female, then the remaining 5 professionals have to be in this category. So we're left with 13 minus 5 equals the amount of male students there are, which is the number 8. Therefore, our answer is C. Cool. So hopefully you can see how drawing things in a different format, in a different diagram, can help with a numeracy-based logical puzzle like this one. Let's kick on to our next question. All right, so our goal here is to find how many blue marbles are there in this particular box. So let's read through it. There's a certain number of blue marbles, 18 red marbles, and 12 green marbles, and Liam needs 2 green marbles. The minimum number of marbles that Liam should pick randomly from the box to ensure that there are 2 green ones is 32. So this is where I want you to almost kind of skip ahead to T here, which is all about testing hypothesis and remembering the worst case scenario. What's the worst case scenario here, right? So there's marbles in a box, and let's just say I'm going to subdivide them into these because I can't be stuffed using different colors. But there's blue ones, there's red ones, and then there's green ones. Obviously, in real life, there's not going to be these dividers. So whoever this guy is drawing out these marbles, Liam, they're not going to know. But what's the worst case scenario here to draw out 2 green marbles? Well, the worst case is you put your hand in, you get out all of the blue ones and then all of the red ones to the point where the only ones you have left in the box are the 2 green, or the however many 12 green marbles you have in here. So that's the worst case scenario. The minimum number to ensure that all the blue ones are gone, all the red ones are gone, and then you take 2 green ones is 32. And so we can represent this in an equation. Otherwise to say, the blue marbles plus the 18 red marbles plus the 2 green marbles that you need to take out to actually meet the condition here is 32. And then so you end up getting the number of blue is equal to 12. So C is our answer. And the way we were able to get to this is by imagining the worst case scenario. Now let's go through just one more question. This one's a bit of a tough one, so pause the video here, have a go at it, and then we'll go through it together. Alrighty, so let's run through it together. Now, in terms of the goal, which of the following must be true is pretty empty. Can't do much with that, so let's skip on to representing. So I'll try and represent as I go, as I read through what I see in front of me. And I find for a question like this, equations are the best. So Rachel has an odd number of stamps greater than 7. So Rachel is greater than 7, and I'm just going to write odd here so I remember, which is the average of the number of stamps that Peter and Quinn have. So Rachel is equal to the average of the number of stamps that Peter and Quinn have. So the way I would dictate that is R equals P plus Q divided by 2. Because if you think about it, if you add up the number of stamps Peter and Quinn have, you divide that by the number of people here, that's 2, then you end up getting the average. So that's going to help us out. Oliver has 10 stamps and Nathan has half as many as Oliver. So we know that Nathan equals 5. Peter has more stamps than Nathan, but fewer stamps than Oliver. So let's depict that. So we've got Oliver here, Nathan here, and we know that Nathan's 5, Oliver's 10, and Peter is somewhere between 5 and 10. Now, we also know that Quinn has 2 more stamps than Peter. So we've basically identified all the information that we can here. So it just comes down to hypothesis testing. So let's go. We know that Peter has to be between 5 and 10. So the number that first comes to mind is 6. We know that Quinn has to be more by 2. So 6 plus 8 divided by 2 ends up giving you 14 divided by 2, or the number of 7. We know that Rachel is greater than 7, so that can't be right. So it's not 6 for Peter. So let's try 7. 7 plus 9, and that ends up giving you 16 divided by 2. That gives you Rachel equals 8, but we know that Rachel needs to be an odd number, so that can't be true either. So then we're left with 8 and 10. So 18 divided by 2, that gives you 9, which meets all of the criteria that we need to. Rachel is an odd number greater than 7. It's the average of the 2, and we're happy. So then, based on that, we can answer the questions. Nathan and Quinn have a total of 13 stamps. So we've got 5 plus 10. That's not true. We've got Nathan and Peter have a total of 14 stamps. 5 plus 8. Again, that's not true. Oliver and Rachel have the same number of stamps. We've got Oliver on 10 and Rachel on 9. That's not true. And then so by elimination, we're left with D. But we can see that it's true. Quinn and Oliver have the same number of stamps. And therefore, D is your answer. So this was just a couple of practice questions that we've gone through. You'll get better and better as you do more practice. And if you don't already have a question platform to do this practice on, then you can use the code Farhan for 10% off med entry. Otherwise, here are a couple of traps that students fall into when it comes to logical puzzles. Number 1 is trying to solve the entire puzzle perfectly, before answering the actual question. 2 is reading clues top to bottom instead of hunting for those more concrete pieces of information first. And 3 is refusing to use hypothesis testing or guessing wildly without narrowing your options first. So here's your do's and don'ts. Do draw a simple table or a diagram for almost every logical puzzle you do. Do start by filling in the concrete 100% certain clues before anything vague. And do use hypothesis testing as a controlled last resort strategy, considering the worst case scenario. Don't try to hold everything in your head without writing. You're going to get lost. Don't feel you have to go top to bottom through the clues in order. And don't insist on solving every detail of the puzzle when the question just doesn't require it. So here's your next step. For the next 10 logical puzzles, I want you to apply the grit method and measure your speed and accuracy as you do your practice.